Alright guys, welcome to the cosine wave. So just like we could graph the sine wave from the previous notes, we're going to start with the graphing the cosine wave using a parent function. So on the unit circle, right, this time cosine is our x values, right? So cosine are the x values on the unit circle. And so the question is, what does the parent function, which is this guy right here, right? What does that parent function look like? Okay, so if we start at 0 pi, so we're at 0 pi, the coordinate right here is 1, 0. If we move up here to pi over 2, the coordinate here is 0, 1. And then right here at pi, the coordinate is, excuse me, negative 1, 0. Down here at 3 pi over 2, we're at 0, negative 1. And then when we get back to 2 pi, we're back to 1, 0. And so these are the values that we're going to use from our unit circle. Again, this is going to be our radians, and this is going to be our now x values. So our radian is 0 pi. At 0 pi, the x value is 1. And then pi over 2. At pi over 2, the x value is 0. And then we've got pi, and the x value is negative 1. 3 pi over 2. The x value is 0, and then at 2 pi, the x value is back to 1 again. So what's different about sine and cosine is that instead of where sine starts at 0, cosine starts at 1. So it's really almost like just shifting the sine wave over. And so actually sometimes like students are like, should I use sine or cosine? And really it doesn't matter that much. You can generally pick either one. Okay, so we're going to start here at 0 pi, and then remember I want to go to 2 pi. So right in the middle would be pi, and right in the middle of these would be pi over 2, and then 3 pi over 2. And I'm going to go from negative 1 up to positive 1. And then we're going to see again that we can also move backwards. So if this is 2 pi, right, but it would be negative 2 pi, then this would be negative pi. And then, of course, negative 1/2 pi and negative 3/2 pi. Okay, we're going to go ahead and sketch cosine. So cosine starts at 0, 1, so 0, 1. And then at pi over 2, we're at 0. At pi, we're at negative 1. At 3 pi over 2, we're at 0. And at 2 pi, we're back up to 1 again. And so you can see, right, I'm going to sketch this guy in here. You can see how cosine and sine look similar. They're both very curvy. The main difference, and it's a little harder for me to sketch this guy, but here we go. The main difference is that it starts at 1 and it ends at 1. All right, but it doesn't really end at 1, right? This is just the time it takes for it to complete one cycle, which is 2 pi. So as we see, if we were to move backward pi over 2, our value would be 0. So if I go back pi over 2, I'll be at 0. If I go back a whole pi, I'll be at negative 1, so that'd be down here. If I go back 3 pi over 2, I'll be right here at 0 again. And if I go back 2 pi, I'll be at positive 1, so up here. And so you can see this graph continues on like such. So you should be able to see the similarity between the sine and the cosine wave. In fact, the parent function, it's like if we just shifted this guy right over like that, we would have the sine wave. All right, important properties. So standard form. The nice thing is once we know how to graph sine, we really do know how to graph cosine. The amplitude A is the distance the graph goes up and down on the axis. So the distance it travels up and down on the axis. The period is still found by 2 pi over b. How long it takes to complete one cycle. The phase shift is the translation left or right. And the vertical shift is the translation up or down. Again, you can use this equation. I don't use it, but you can start and stop using these formulas to figure out where you should start and stop. I personally don't do it that way, but you are welcome to do it. So Let's go ahead and flip over and do a few examples. Oh, good, there's only 2 examples. All right, so 2 examples. Let me make sure that we're not off the graph or off the screen. We're not, we're good. Okay, so the first thing I'm gonna do is determine if it's in standard form, which it is. So I'm gonna identify A. Absolute value of A is the absolute value of 1, which is 1. So our amplitude is 1. So we'll move up 1 and down 1. The period, right, the period is the value for B. It's 2 pi over B, which is 2 pi over 1, or 2 pi. So our period and amplitude will not change, but we will have a phase shift. So our C value is negative pi over 2. Be careful. Oh, remember this, right? This should be a negative. It became a positive. And then our final item would be our Y value right here, or D, or shift up or down, which is 0. So we're going to start with the parent. I'll start at 0 pi. I'm going to go to 2 pi. No reason to change my my period. Okay. So I'll graph my parent. My parent starts at 1 this time, goes to 0, then to -1, then to 0, back up to 1. So here's the parent. And we're going to shift everything pi over 2 to the left. So that means that I'm going to move every point pi over 2 units. This is an easy one because we're already counting by pi over 2. So this point will move pi over 2. 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 And this point will move pi over 2. And here is our final graph. Okay, I guess I could go ahead and connect, right, these formulas to what we had. So in this case, B was 1 and C was negative pi over 2. And so if I wanted to start, I could use this formula to see where I would start. So I would plug in 1 and then x minus pi over 2, right, which would be plus pi over 2 equals 0. And then I would solve for x. So this would be x equals negative pi over 2, which is where we started. And to stop, again, plugging in the same values, I'd have 1 and then x minus negative pi over 2 equals 2 pi. And again, solve for x. I'd get x equals, I'd subtract pi over 2. So if you subtract pi over 2 from, this is 4 pi over 2, so minus pi over 2 would be 3 pi over 2. And so we would stop at 3 pi over 2, and we do. We started at negative pi over 2, and we stopped at 3 pi over 2. So if you want to apply that to the sine wave as well, yay. Okay, next one. We have plenty of room, so we need to first determine if it's in standard form. And this time I see that it is not. Remember that there should not be a value in front of the x term inside the parentheses. This value needs to travel outside. So what I'm going to do is I'm going to start with taking the 1/3 x minus pi over 6, and I'm going to factor out the 1/3. And so just like I showed in the previous notes, some of us can tell what number needs to go here, right? It's minus something with pi in the top, but some of us cannot. So I'm saying 1/3 times some number, some number equals pi over 6. So 1/3 times some number, I'll call it y, equals pi over 6. And then I would multiply by 3, and I'd get y equals 3 pi over 6, which is, excuse me, pi over 2. So this should be pi over 2. And if I multiply top to top, bottom to bottom, I will get pi over 6. So now I'm going to rewrite my equation. Y equals 2 cosine. The 1/3 comes out, and I'll have x minus pi over 2. And then minus 1. Okay, now I'm going to identify my amplitude. My amplitude, absolute value of 2 is 2. Now remember, if it was negative, we would just flip the graph, just like we did on the previous notes. The B value, right, so B tells me my period. So this time it's 2 pi over 1/3. So 2 pi over 1/3 is the same as 2 pi divided by 1/3, or 2 pi times 3 over 1. Or you could just multiply the top and bottom by 3 right here, and you'll get 6 pi. So this is my period is now 6 pi, so it's elongated that cycle. It'll take a whole 6 pi to complete one cycle. Let's go ahead and identify our phase shift. Our phase shift is C, which is pi over 2. And then our horizontal shift, which is D, -1, so down 1. All right, I'm going to go ahead and graph this one up here just because I'm kind of running out of room, so I'll do it right here. So what I know is it's going to take 6 pi to complete. And it's also going to move over pi over 2. So if we want to know where to start and stop, you can use that formula again. I'm not going to do it that way. So here's my 0 pi. Whoops, here's my axis, right? I know that I need to be able to move, stretch by 2 and move down 1. So I'll count to make sure that I get to -3 here. All right, this time I know it takes an entire 6 pi to complete my phase shift. To complete my cycle. So that means in between, I'll be at 3 pi. And then halfway in between 1 and 3 is 1.5, which is 3 pi over 2. And halfway in between 3 and 6, excuse me, so this is 3 pi over 2, right? This is 6 pi over 2. So I'm counting by 3 pi over 2 each time. So 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. And then this would be 12 pi over 2. All right. Now, I guess I will go ahead and show that start-stop. So let's do the start-stop. It's fine. So to start, I would use this, right? B x minus c equals 0. And you can go ahead and plug in b and c. I don't know why I put 3 there. C, x minus c, my bad. So I'll go ahead and plug in my b and my c. Remember that b was right here, 1/3. X minus c, and c is pi over 2, equals 0. So I'd multiply by 3. That wouldn't do anything to this side, but I'll multiply by 3. That'll cancel out. And then I'll move the pi over 2 over, and I get x equals pi over 2. So I'll start at pi over 2. And then I will end at b x minus c equals 2 pi. So I'll plug in my 1/3, x minus pi over 2 equals 2 pi. Multiply by 3. This time I'll get 6 pi. So you can see where that 6 pi came from. And then 6 pi over 2, 6 pi over 1 is the same as 12 pi over 2. And I'm going to add pi over 2 to it, so that'll be 13 pi over 2. So I'll end at 13 pi over 2. So this time, I'm going to stretch this out just a bit. I'm going to start at pi over 2. And remember, this is 3 pi over 2. So 1 pi over 2 would be about right here. And then each of these points really is just getting shifted. This is why I don't necessarily do it this way. But each point is just getting shifted to the right by pi over 2. Okay, so that's where we'll be starting at. And we'll be ending over here at 13 pi over 2. I'll go ahead and put those two on here right now. Okay. All right, so I'll start with the parent, that's 0, 0, 1. And then I would be at right here, 0, right here, -1, right here, back to 0, and right here, back to 1 again. So I adjusted my period by making one period take 6 pi. Now everything is going to shift, right, and stretch, and et cetera, et cetera. So the next thing I'll do is I'll go ahead and I will stretch the graph, right? So it's going to have now an amplitude of 2. So rather than going up 1 and down 1, it's going to go up 2 and down 2. And so here's my vertical stretch. Now the last things I need to do, I need to shift pi over 2 to the right. So every point is going to move pi over 2 to the right. So this point will move to right here. 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 And then this point will move to right here. And I'll sketch it in again. And then finally, the last thing I'll do is my up or down shift, which is down 1. That means this point will move down to here. This point will move down to here. This point will move down to here. Oh, I'm sorry, wrong one. This one. This one will move down to here. This point will move down to here. And I did it again, my bad. This point will move down to here. And this point will move down to right here. That one. And so the graph will look something like that. All right, guys, that's really all the notes that I have. I'm going to post both of these assignments, and there's a second follow-up worksheet for both. So I hope you have a good evening. Bye-bye.